All right, so a couple of updates to the website. The where I was hosting the website, that's no longer available. So I'm moving all the content on Blackboard. So all these slides are now available here. So you should be able to view them right here, as well as all the videos are under here. Okay, so you should be able to view all the content here, and I encourage you to go over that here. Also, the at the beginning syllabus, the agenda is also available through here, and now the links are all valid. And so I'd like to go over the next assignment, assignment 4. All right, so this week's assignment is to refactor what you have so far for the mean application, where you now currently are hosting all the data on the client side. Right, you have some kind of you have some service client that has data, mock data for the users, mock data for the websites and pages and widgets and whatnot, and starting to move all that data over to the server where it belongs, right? Well, eventually it will belong in the database, right? But the first step would be to move it over to the server. That on itself has its challenges, right? Whereas right now the client that is rendering it and the components and the services all are being hosted on the browser, and they're all running on the same machine. They're all running on the same process, right? So when you query for a list of users or a list of websites or a list of any data model or any data set, you get the results immediately, okay? Because it's all in the same thread. When you start now partitioning it into multiple tiers, then it becomes a little more challenging, right? When you move it over to the server side, when you move over the data to the server side, now that you have to make a separate HTTP request to retrieve the list of websites or retrieve the list of pages or widgets or whatnot or users. Yes. And because you have this added connectivity, this added network connection, the client no longer can rely on the data being immediately available. Okay, it has to instead do a multi-process communication and wait for the server to respond, right? And because there might be some latencies, the client, since the browser only has a single thread, it can't risk having that single thread just blocked, waiting for the server to come back, right? So it has its own challenges on how to deal with this multi-process communication using asynchronous communication as opposed to the synchronous communication that we've had so far. So what this assignment asks you to do is to move all the CRUD operations that you worked on in the previous assignment that you implemented on the client service, right? To move all those CRUD operations over to the server side, right? And implement them using web services. Right, using what we just talked about, right? Exposing those URLs, right? That allow you to create, delete, update, right? Or read lists of whatever you want. Okay, so you'll be creating service or server versions of the client services that you've been building for the previous assignment, right? If for the previous assignment you created user.service.client.js, right? And website.service.client.ts. Yes, you've created all those services. Well, now you're going to create sister or mirror images of those, but on the server side. Okay, and they're going to be running on a separate thread, right? On a separate process, running on a node server, right? It'll be on the same machine for now when you're developing, but when you deploy to Heroku or whatever server you're hosting this, you'll literally have two separate machines talking to one another, right? You'll have your browser talking to a remote server asking for data, right? And it'll have a network connection to do that. So this is where you're going to implement the server side of this, right? You'll have an entry point to your server side app implemented in app.js, and we'll see that in a minute. And in there, you will implement the various services in a service directory. And in that service directory, you will implement the user service, the website, page, and widget. Right? So these are going to be implementing web services. Web services. All right? Web services, they became very popular in the turn of the century. And we thought web services was going to solve every problem, right? That was going to allow us to interface and interact with all sorts of disparate systems. It turned out to be much harder than we thought, but today, they're very popular. There's tons of APIs and web services out there providing all sorts of free and interesting data, and we're going to be creating our own web services, right? Implementing this simple data model, right, of users and websites and pages and widgets. Okay, so we're going to instantiate our service and load a couple of libraries that will allow us to parse data back and forth between the client and the server. The server is going to be sending data across, right? JSON objects. Hey, create this brand new user, or create this new website, or create this new page. It's going to be sending JSON object across the wire, right? And the server is going to need to be able to parse this, right, from the HTTP request, right? So we're going to be loading a couple of libraries that allow us to do that. Body parser will allow us to parse the JSON object from the request. And for each one of the services, you're going to be creating these URL patterns. So we're going to prepend all our URLs with /API, right? So to distinguish these requests from static requests, right? We're going to be asking for data or creating data, and we're going to be implementing the same exact CRUD operations that we were doing on the client. We're now going to move them over to the server, okay? Behind a RESTful web service API, okay? So we're going to have post is going to implement the create. We're going to have 3 read operations, 1 update operation, and 1 delete operations. Oh yeah, so sorry, it's not update, it's put. Put is the HTTP method that implements the update, the modification of something that already exists. Okay, so yeah, here's our data our data type here is that we're manipulating a collection of users. So post to this URL is interpreted as add a brand new user to the collection of users, right? Get with a particular user ID means I want to retrieve that particular user that has this particular user ID, and please return the object that represents that user. Put with the same URL means here's brand new data that I want to use to update an existing user whose ID is so and so, right? Whereas delete means hey, there's a user whose ID is user ID. I want to remove it from the collection of users. Make sense? Right? Notice that the URLs look very similar to one another. The server needs to be able to distinguish between them, right? Since they are all the same URL, the server is able to distinguish them using the action, right? It can distinguish whether there's a get and a particular URL, and then the put with the same URL, right? It understands and maps them to different actions, right? And we're going to map them and implement them in these functions on the server. Same thing for the websites. We're going to post to a website. Notice the syntax here, and notice that it's which reflects on the relationship between a user and a website, right? A user is the owner or the parent of a particular website, right? So that's creating a new instance of a website and creating the relationship between a user and its child website. Get for that website, since we're not specifying which website, it means that I want to see all the websites. Well, actually not exactly all the websites. Notice that we are prepending it with /user ID, meaning I don't want to see all the websites. I only want to see the websites with this relationship between a user and its child websites, right? So this returns a subset of websites whose parent or developer is user ID. Make sense? Now it might make sense that you can list all the websites irrespective of who the developer is. So we would allow to do that by something like this, where we would have a get and then no user in front of it, right? If that would be a valid use case, right, where I like to be able to see all the websites, right, regardless who the developer is, right? Maybe a system admin might want to do that, right? I want to see all the list of websites. Maybe not for an individual user, right? If I'm a user, I only want to see my websites. I don't want to see somebody else's, my neighbor's websites, right? But maybe a system administrator might implement or need this use case, okay? So I'm going to remove that. Delete row. There we go. Same thing for the page. Here we're creating a particular page for a particular website. Presumably, I already know who the user is. That's how I got to the website in the first place, right? And then I'm asking to create a brand new instance of a page for that website. Same thing, being able to update a page, or delete a page. Okay, same thing for widgets. Then we're going to have to refactor all the web services, client web services that we wrote in Angular, right? They were all implemented hard coding the mocked data, right, locally in the website, in the client web services, right? The list of users, the list of websites, all that is going to move over to the server, right? We're going to move that over to the server, and we have to refactor them so that instead of, for instance, instead of find user by ID, iterating, looping over the list of users, finding the user with that ID is, and then returning that instance, instead is going to go and fetch the data from the database, from the server, right? And to do that, it's going to access the ID, the URL that's mentioned in the table above, right? And provide the ID over to the server, and the server will respond with a JSON object, presumably representing that user with that ID, right? So the iteration, the for loop, is going to happen on the server. All right, so almost the same exact code we have now on the client is going to move over to the server. Okay, with the only caveat that on the server you are participating in an HTTP request response cycle. Right, the client is sending a request. Right, the server is handling that request, looping and looking for that user, and once it finds it, it then responds to the client who's waiting. Right, the request went out. Right, the client is kind of waiting. Right, and the browser is blocked, right, waiting for the response from the server until the server then responds back to the client. And here, the client is parsing that as a JSON object and just returning it over to the component. The component, instead of it used to be that we would call the service, and the service would immediately respond with the object, right, of the user who just logged in, or who just we found with that user ID, username, or password. Instead, we're going to have to asynchronously, right, use the service that goes out to the server, eventually comes back, and it notifies us either as a success, right, or it comes back with some error from the server. Okay. Also, in this assignment, we're going to work on being able to actually move around the widgets, right? And on the previous assignment, the widgets were static, right? What we're going to be working on is being able to actually drag them around, right? And store their new positions on the server. Right? The server is going to retain their new position so that when we come back later on and we log in, hopefully the widgets will be in the order we left them. Okay? Right now, if you refresh the page, all the widgets are gone. They're not longer there. Right? There's no session information. Instead, we want to make that permanent, at least as long as the server has been running from the last time, right? As long as it has been booted from last time. When we introduce the database, we're going to again revisit this, right, to make the changes permanent on the database. Right? So even though the server might reboot, we will still have that information stored permanently on the database. So here's some examples on how to do it using directives, and we'll take a look at that perhaps next week. Also, the image widget asks you to be able to upload new images, and so here's an example how to do it using a form and submitting to a server as a posting a brand new image to the server, and being able to handle it on the server and being able to copy that image to a local folder on the server, right? Which then can be referenced by a widget so that it can be rendered on the widget. So this gives you some startup code to be able to do that. It also asks you to enhance the image widget so that not only can you upload an image, but search an image from an API. Here I'm suggesting that you use Flickr API to search for images. Some students prefer to use Google Images Search. That's fine. If you prefer to use Google Images Search, that's okay. But the example that we give you here is how to search for a photo on the Flickr API, where you can provide some textual context, right? And then it filters images by that text, and we'll create this in class to show you how you use this Flickr service. Okay, but nevertheless, here's the code that you can use. This is a working example, and I encourage you to try to get this running and in your assignment. I think. All right. Wait, did we? Oh, I'm sorry. We moved the Flickr image to the next assignment. I think there was a little bit too much. But if you want to start experimenting and getting it going in this assignment, you're welcome to start playing around with it in this assignment. But yeah, we'll make it a deliverable for the next assignment. All right. All right. Great. Let's start playing around with server-side programming.